So now we want to set the viewing of the draft on geography. So I opened up the structure file here. Let's say this is our area, and then we have the 3D on the right, and we're in the level, let's say 7600. So we can go over here and select the floor that we have and temporarily hide it from this section and this option down here. Alright, so let me just go over here and press hide so that the area is just a bit more secluded. Alright, and let's just see. Alright, after that I can open up the dynamo and maximize it. But before we start, because we want to work on this area here, I'll first go over to the architecture tab, and using a model line, I'll draw a line here in the 2D plan that goes horizontally through the plan, and it starts from here and goes to the left, and it ends in this point. And then let me just maximize the 2D plan so that you can get a better view of it. And all right, so then to start the process, we can maximize the dynamo and then search for select model elements. So I'll go over here, and in the search I'll look for select model elements. There we go. Then we can select this and open it up, and we need another one as well, but this time we'll look for select model element. Open it up, put it on manual settings, and then save it. Then I'll click on the select in the select model elements, and then in the 2D view that we have of the plan, I'll use click drag to select these, or you know what, cancel. Let's do something else. In order to be sure we don't select extra elements, I can first select the whole area using the click and drag. Alright, and then I can open up the filters menu, press check none, and then from the categories I'll only select generic models and lines, and then the structural framing of the girder, the joist, and the other. Okay, and then I'll press the isolate element option as well, and now it's just a bit better. Alright, so the area up here goes in the first one, and this goes in the second one. After that, we can go over to the search bar, and this time we can look for elements.geometry. Now this allows us to see the items in the background of the dynamo as well. So I'll open up the geometry and connect it to the elements. After that, I'll get a base copy of it and connect it to this one, and then I'll hit run. Alright, we'll just have to wait for it to process the commands and then give us the results. Alright, and there we go. So now we have only one item down here, but let's see how much we got in the first element. I'll look for the flatten app and open that up and connect it to the element and then hit run. Alright, after that I can right click on the element.geometry and then select the preview option. This deactivates the preview, and now we want to find the collision or clash points in between these. So this time we'll go over to the search bar once again and look for geometry.intersect. Alright, then open it up and pull it over here. Now the outcome of the element geometry gives us a variable, but we want to change that into a vertical line. So inside of the search bar, I'll look for vertical plane by line. Then let's see, we have this which we can open up. Now this requires a package called Practical Beam to be installed. So I'll select this, and the Dynamo version that I'm working with right now is 2.5 on the 2021 Revit. And the upside to this is if you open up the script on your own system and the program doesn't run it, a window opens up here that you can also access from the View tab, and the packages that I've needed to use but haven't installed them on my system or your system are shown here. And you can directly install them here, which is a feature installed for the 2021 version. So I'll connect these two and then hit run. Alright, let me just right click here and deselect the preview and do the same for the line as well. And then this is the plane that is created here, our cut plane. Alright, so now we can see the empty list in the geometry. So we'll right click on the geometry itself and put the lacing option on the longest. Press run. Alright, and now it's received the amounts. But now we want to turn these into a draft view. So now I can zoom in here and select this line and bring it down here where we have the rebar. Alright, now we can press run once again. And alright, let's see what we get. After that, let me just bring this over here. Now this one has an intersection with just one, so we can go with that, but also like this, and then select this area on the plan and hit run. Then we just have to wait for it to be done. So as you can see, I did the job of relocating these, which improves it just a bit. And now we want to create the drafts. So after that, I'll right click and look for flatten and then open it up. Alright, then connect it to the geometry and hit run. Now this gives us the surface list, and then after that, we can use first item. Connect that to the variable from the list flatten and then hit run again. And there we go. After that, I'll go up to the search bar up top, and this time I'll look for coordinate system from surface. Then we'll see what we can get. It's this tool right here, which requires the same Practical Beam package. So I'll select that and then I'll connect it. Our item is the base surface and the vector is the plane that we created over here. Alright, then I'll hit run. And let's see what the warning is here. It says it doesn't receive any vector because we connected a plane to it. So before we connect these two, we'll need to go over here in the search bar and look for line.direction. Now this converts the line to a vector. So we put that here where it acts as a converter, and now it should be fine. Alright, so the problem is solved there, but we have a warning on the line direction. We've connected a plane to it, but it should be a line instead. So I'll connect this one to it and then hit run. There we go. So, alright, after that, I'll go over to the search bar and this time I'll look for geometry.transform. Alright, select the second one through the list and open it up. Now we can see the options here, the geometry, the from coordinate system and the context coordinate system. Now our geometry connects to the flatten. Let's see where that one is. So connect these two. And then the next one from coordinate system can be connected to the coordinate system over here. And then we have the context coordinate system, which we need to create a coordinate system for. So search for coordinate system dot by origin, which gives us this. Select the origin and load it up, and we can connect it to the geometry from the point, and then we can look for point XYZ and connect that to a coordinate, which gives us the 0 points, and then we can hit run. All right, so I think I've selected the wrong option for this because the start point should be origin. All right, so open this one up instead and delete the last one and connect it to the script. And there we go, problem solved. And then I can right click on the geometry and put the lacing option on longest, hit run, and the transfer will be done for the specific amount that we have here in the base point. And each one of these can be a drafting view. So now we want to change the selection. We can adjust the length of the line. For example, bring it over here. Or you know what, bring it to the left because we have less items there. And if we just have these, it's fine. So as an example, I can go over to the select model elements and then press select and then select the elements that I want from the model, which are these, and then hit run. And all right, you can see the changes in effect. So let me just select these and deactivate the preview option, and then do the same for the flatten and then this one as well, and the geometry intersect as well, so that we can zoom in. All right, uncheck this one as well. All right, then we can right click here and deactivate the line direction as well. Let's see what else we have, and right click and deactivate the preview here, which leaves us with only the geometry. All right, so now we want to create a drafting view. So in this part, I can go over to the search bar and look for surface.perimeter. Let's see what we get. Open this one up. It's not this one. Now this gives us an output of curve from surface. So I'll connect it to the script and hit run. Uncheck the preview on the geometry, and you can see we get the exact shape that we want. And all right, after that, I'll look for detail curve dot by curve. Select this, and well, first the curve is here, and then we can look for the drafting view. So in the search bar, I'll type in drafting view, and then open this one up that says by name, connect that to the view, and then let me just add a string as well. Bring it over here, connect it to the name, and then in the string itself, we can type in structural cross dash section. And all right, there we go. After that, I can press run. Press delete element on this, and it basically says the line is too short, which is natural because in some of the spaces here we have lines that are too short. So I'll go over here, open up the drafting views, and double click on the structural cross section, which opens up the shape of the draft for us here in the Revit as well. So that's how we can create a draft based on a 3D model. Now we can also put in some adjustments here if we want. For example, these are where the joists go. So I'll put in some distance between these, and then let's see, put in some distance between these two as well. And then I can put in some measurements for these. For example, the joist gives us 0.14 and then 0.56 on here. Now here we have to either draw the line ourselves or create an intersection in such a way that it gives us the line. And these are the specifications of the beam. And we've basically done this based on the geometry